Occasionally when we're solving inequalities, it's necessary to solve multiple inequalities at once. And how we combine these inequalities can be done in one of two ways. We can combine them with an or, meaning we need the solutions to only satisfy one of our inequalities. Or we could combine it with an and, where we would need the solutions to satisfy both of the inequalities. So let's look at some examples of these. So we have 6 is greater than 3x plus 9, or 13 is less than or equal to 2x plus 5. So in order to solve these, we need to start by solving them both out. And so we'll start with the one on the left. And to solve that, we start by subtracting 9 from both sides. So we can do this, and that gives us negative 3 is greater than 3x. We then divide both sides by 3, which gives us negative 1 is greater than x. We then move to the inequality on the right. We start by subtracting 5 from both sides. That gives us 8 is less than or equal to 2x. We can then divide both sides by 2, and we get that 4 is less than or equal to x. In order to figure out the interval notation for this, it might be simpler to start with the graph. So that's where I'm going to start. So I have my number line, negative 1 is about here, and 4 is about here. The first inequality says negative 1 is greater than x. So first off, we need an open dot since we're not including negative 1. And you'll notice x is the smaller of the two. So we need to shade to the left for that. My second equation, I'm going to put a closed dot on 4 since I'm including it. And I want 4 to be less than or equal to x. So I want x to be bigger than 4. So I'm going to include all of this stuff to the right. And now I can kind of get a better idea for the interval notation. This piece on the left is negative infinity to negative 1 with parentheses. The piece on the right is 4 comma infinity with a square bracket on 4. And we want to include one or the other, so we use this symbol that kind of looks like a U. It stands for union, which just tells us that we have to be in one of these two intervals. We don't have to satisfy both. We just need to be in one of the two. For my next one, 7 is greater than 2x minus 3, or 10 is less than or equal to 5 minus 3x. So once again, let's start by solving them individually. We start by adding 3 to both sides. That gives me that 10 is greater than 2x. I can then divide both sides by 2 and get that 5 is greater than x. So then we move to our other equation. We start by subtracting 5 from both sides. That gives us that 5 is less than or equal to negative 3x. We can then divide both sides by negative 3, which gives us that negative 5/3 is greater than or equal to x, since we'll need to switch our inequality since we divided by a negative. So once again, let's start by thinking of the graph of this. We have 5 and negative 5/3. The first equation says I should put an open dot on 5, and I want x to be the smaller of the two, so that means I would need to shade to the left. The second equation says to put a closed dot on negative 5/3, and once again I want x to be the smaller of the two, so I would shade to the left. So we can see in reality here our interval is just negative infinity to 5, since everything in this interval satisfies one of the two inequalities. Now let's consider an and inequality. So I have negative 16 is less than or equal to 2x minus 6, and 3x minus 15 is less than 3. So once again, we need to start by solving each individual inequality. We start by adding 6 to both sides. That gives us that negative 10 is less than or equal to 2x. We then divide both sides by 2, and I get that negative 5 is less than or equal to x. Now let's move to the other inequality. We start by adding 15 to both sides. That gives me that 3x is less than 18. I then divide both sides by 3, and I get that x is less than 6. So let's think about our number line once again. We have -5 and 6. I have a closed dot at -5 and an open dot at 6. I need numbers that are bigger than -5. But at the same time, I need numbers that are less than 6. So we can see that all of the numbers between -5 and 6 do satisfy both of these at the same time. So I'm considering the interval from -5 to 6, where I use a square bracket on -5 and a parentheses on 6. For my next one, let's consider 3x minus 4 is greater than or equal to 2, and 2x plus 7 is less than 1. I start with my first equation by adding 4 to both sides. That gives me 3x is greater than or equal to 6. I can then divide both sides by 3, and I get that x is greater than or equal to 2. For the second equation, I subtract 7 from both sides, and that gives me 2x is less than -6. I then divide both sides by 2, and I get that x is less than -3. So this one's a little bit trickier because I need values that are bigger than 2, but at the same time they have to be smaller than -3. And we can see that there's no number that satisfies both of these inequalities. There's no number that at the same time is larger than 2 and smaller than -3. Therefore, this system has no solution. Occasionally, we might need to solve problems like this. 2 is less than 6x minus 4, and 6x minus 4 is less than or equal to 8. So I can see they both share that 6x minus 4 term. And so a lot of times we usually combine these types of problems to simplify them. So instead, I would write 2 is less than 6x minus 4, which is less than or equal to 8. With an equation, we would need to add 4 to both sides. But with these type of inequalities, we need to add 4 to all 3 sides. So anything we do to one side, we need to do to all 3 sides. That gives me that 6 is less than 6x, which is less than or equal to 12. I then divide all 3 sides by 6. And I get that 1 is less than x is less than or equal to 2. In interval notation, we can write this 1, 2 with the parenthesis on 1 and a square bracket on 2. If I'm thinking of the graph, on the other hand, since we don't include 1, we'll have an open dot, and 2 will have a closed dot. And we need numbers that are bigger than 1, but at the same time less than or equal to 2. So we would shade in the center.